So we tend to organize our perceptions in pretty predictable ways. So we're born with tendencies to organize sensory information, and we constantly make use of those things. So what do you see when you look at this picture, for example? You might see all kinds of things depending on how you're organizing your information at that time. You might see horses. Actually, it can take me a second to see the horses. I see the trees. I see men's faces. Horses are in here. Oh, now I see horses. But that's the idea behind perception. We tend to look at the same thing and see multiple kinds of things in here. And of course, artists have used that to their benefit for quite a long time. But one of the ways that we organize things or kind of recognize things is using certain principles called Gestalt principles. So these often provide accurate information about properties in the environment, in other words, what we see. They tend to reflect our experience and are used unconsciously. They happen pretty much automatically. Interestingly, they can be misleading at times. But these things are heuristics, that is, they're rules of thumb. They don't work every time, but they work most of the time. And they kind of provide a best guess or a solution to a product. It's fast, it's often correct. Like I said, it rarely, though, it will lead you astray and end up providing kind of a misleading information. But the word Gestalt comes from the German word for whole or form. The whole of a perception basically is greater than the sum of its parts. That's what it's really describing. So when you look at your friend's face, for example, you perceive their face. You perceive your friend. It's not a sum of angles and curves and shapes and lines. You perceive a person's face right off the bat. And your mind implicitly groups these stimuli that make up the face into a coherent whole. In fact, it would be really difficult if you could separate those things or to try to separate those things so that what you really focused on were the angles. It would be very difficult to do that because what you see is a face. So these perceptual laws, these Gestalt laws, attempt to explain how our mind automatically organizes these stimuli together to produce the perception of a whole form. So let me give you some examples. One is called the law of good figure, or the law of Prägnanz. The notion is that every stimulus pattern that we see so that its resulting structure is as simple as possible. In other words, we're constantly trying to simplify our world. I can't recall if I've mentioned it before, but basically our brain is about 2% of our body weight, but still uses 20% of our glucose. So it's very kind of, it uses a lot of energy, and because of that, it tries to interpret the world as simply as possible so we can use a lot less of that energy. So you can see here's an example. These are 5 rings, sort of like the Olympic rings, but we see them that way, but they could just as easily be a set of several kinds of things like this. It's just that this is more complex. It's much easier to see these as overlapping, and that's exactly what we do. Another kind of Gestalt principle is the figure-ground relationship. We sort of assume that things occur in a context, and the context tends to have a background and a foreground, and it's usually the foreground, the thing that we bring to the front, that we're most interested in. So we identify a main object in a scene, we call that the figure, that stands out against a background. And we assume that the figure stands in front of the ground, and it seems to have more substance in shape. So you can see that example here. This was a vase actually created for Queen Elizabeth of England, her anniversary with Prince Philip. And in this particular case, you can see Queen Elizabeth over here, if you allow yourself to pull that background forward, and Prince Philip over here. Pretty cool. That's what we mean by figure and ground. And you can see that all the time. This is a pretty interesting medical illustration person at Crane Studios here, but you can see, or Crane Studios, you can see the foreground being shown because it's more vivid here in front, and the background going into the background that shows kind of the vascular structure of the brain. Here you see the carpal tunnel syndrome, area, again by showing something more vivid in front and letting the rest fade into the background with more muted tones. Here's another example. We tend to group similar kinds of things together. So when we look at this, we can see that, boy, we tend to think about this as being oriented in columns, looking down, as opposed to rows. And we do that simply because we've kept those things that are most similar oriented in columns here, and those things that are more similar oriented in rows here. So we have this sense that similar things go together. We group them together automatically. It doesn't take a lot of work from us. It happens just as a matter of course. Here's another example, continuity. We tend to see things continuously because we tend to expect things to be simple. Simple things tend to be continuous. So this could be multiple, of course, things that are sort of placed in kind of strange ways together, or it could be one continuous knot, and that's exactly what we're seeing here, because that would be more common probably in our world. Here's another one that's absolutely critical to user interface design. One of the most powerful tools I've experienced in the design of user interfaces is just plain old proximity. Things that are close together tend to be thought of as highly related. So even here you can see there's slightly more distance between columns than there are between rows, and as a result we tend to look at these things as grouped by columns. On the other hand, if we just stretch it out a little bit so that there's equal amount sort of space between these two things, it's hard to tell, are they in columns or are they in rows. Proximity is incredibly strong sort of cue in understanding how things relate. Proximity is so strong it can actually go wrong at times. Here's an example of this. In this particular case, something just got scooted over a little bit. Something that should have been straight up here is now tilted a little bit. So now it says that anal exams are actually being conducted at Lexington Middle School instead of final exams. And that's enough to keep you away from school. So that's just a very small thing that's changed here in terms of proximity, yet really makes a difference. Here's another great one. Here's a situation where they didn't use proximity well enough at all. So it looks like it's diesel fried chicken, when in fact it's probably diesel and fried chicken. But because their proximity was off just a smidge, wasn't much, it has a completely different meaning. Here's another example. This is the law of common fate. Things that tend to be moving in the same direction appear to be grouped together. Pretty straightforward. There's also the law of familiarity. Things are more likely to form groups if they appear familiar or meaningful. There's also the principle of closure. That is, we have a tendency, because we're trying to simplify things, to kind of close figures that seem like they should be closed. And you can see that example here in both of these cases. The World Wildlife Federation panda on our right-hand side is a great example of that. And things that are placed in a common region tend to be seen as related. So basically it's easy to group things just by putting a little border around them, and then you think of them as part of the same whole. You'll find that things like grouping like this, that is common region, as well as proximity, are two of the strongest things to display that things belong together. A final one, one of the final ones, is mapping. And you can see a problem in this particular stove here. This is a common illustration in all your engineering courses and so forth. In this particular case, it's really difficult to determine which one of these burners goes to which one of these dials. Here's an even worse situation where it's hard to determine which one of these burners here go to which one of these dials. That's an example of bad mapping. So people again often ask me things like, how should I be designing things with kind of vision in mind. And I'm going to go back to a few of the very simple things that I mentioned before, especially with color. I tend to design for monochrome first. And again, one of the reasons I'm doing this is because proximity and region are such strong cues, and they do an awful lot of work for us, that I want to accomplish that first. And then I tend to apply colors to screens, especially in icons, but I use them very sparingly. I also use colors consistently. Because colors are so strong and attention-getting, I tend to use them to get attention. I tend to combine them with other types of highlighting. I always use light backgrounds for the main areas, off-whites and grays and things like that, and I use darker areas for the foreground. I tend to use a lot of contrast. I avoid small detailed blue text. Remember, there aren't blue cones basically in our fovea, so as a result it makes it really hard to see detailed blue text. Now I do want to point out one thing. That doesn't mean I think that big swatches of blue are bad. Actually, they're great often as background colors and things like that. On the other hand, what I'm saying is that if you have to read some very fine text or look at something that's very fine, blue is probably among the worst colors to use, simply because you don't have blue cones in the fovea. And of course, for that stereopsis reason I mentioned before in the previous previous video, I tend to avoid red-blue combinations wherever possible.